Hey, we have your Taylor integral from the MIT Integration Bee 2023. This was regular season problem 10. We have the integral of sine 2x cosine 3x over sine squared x cosine cubed x dx. Okay, the thing that I noticed first is just the fact that we've got different angles going on. We've got 2x here, 3x here, and then we have x's in the denominator. And what I'd like to do is get everything into x. And so what I'm going to need to do is transform the numerator. We're going to need the double angle formula for sine, and we'll need a triple angle formula for cosine. Okay, so we have our double angle formula for sine right here. This one should probably look pretty familiar. And this triple angle formula for cosine, I always forget this one, so I actually had to look it up. But what I want to do is use this, and we'll plug both of these values into the integral, and let's see what we have. Okay, so now I've just rewritten this, transforming the numerator with our two formulas over here to the right. Of course, I didn't really plan my space very well, but I think you can see what's happening. And so you'll see with the double angle formula, I just took this too, and we brought it out front of the integral. Now from here, what I'm going to do is we can just cancel sines and cosines because we're multiplying this. So if I cancel one sine with one sine here, we're down to a sine x. And then we'll do the same thing, we'll cancel a cosine with one of these. So now this is a cosine squared. And then from here, what I'm going to do is I'm going to rewrite this, but I'm actually just going to factor a cosine x out of this expression because we have cosines in both terms. So we'll factor out a cosine x and we'll have cosine squared x minus just a 3 there. And then here we're going to have sine x cosine squared x dx. And then again, I'm just going to cancel one cosine with a cosine here. And at this point, I think we've simplified it quite a bit. So what I'm going to do is, now I can break this with this minus sign here. I can break this into two integrals. I'll distribute in this 2. So this first integral, I'm going to have 8. And then we're going to have cosine squared here in the numerator for this one. Then we'll have sine x cosine x. And then for the second integral, I'm just going to distribute the 2 into the minus 3. So I'll have a minus 6 here. I'll put my dx there in the numerator. We're just going to have sine x cosine x. But again, here I can cancel one cosine with this cosine. So now we have this thing where it's actually cotangent of x. But I think we'll leave this one as it is. Now for this one with sine x over cosine x, we do have a 1 right here over the dx. So I'm going to do with this 1. We can do a little trick. We can use the formula. Let me just write this over here. This is kind of sloppy, but we have the formula sine squared x cosine squared x equals 1. So what I'm going to do is take this 1 right here and replace it with sine squared cosine squared x in order to get some simplification. Okay, so now I brought in my sine squared plus cosine squared x for the 1, but I did kind of skip a step. But what I did is I actually distributed in this minus 6 and split it into two integrals. So that's how we have a minus 6 in front of these, and we've split up our sine squared x cosine squared x from this formula right here. But what that's going to allow is some more simplification. So we can cancel one sine x with the sine x here. I can cancel one cosine with this cosine here. And now we're left with tangent here, and then both these are cotangent. So I can actually combine these two because these are exactly the same. We'll take 8 cotangent x here and subtract minus 6 cotangent x here, and we'll end up with 2 of these. Okay, so now that we've combined these cotangent integrals, I think we're in a good position to finish it off. So first, let's just integrate this. So the integral of cotangent x, or cosine over sine x, is going to be just natural log absolute value of sine x. And the integral of this is going to actually be natural log of absolute value of secant x. But what I think I'm going to do is actually take this minus sign and bring it in here to get the reciprocal of this. So the reciprocal of secant x is going to be cosine x. So for our final solution, we'll have 2 natural log sine x plus 6 natural log cosine x plus c, and that's it. Okay, kind of a quick trig integral, so we'll stop it there. Thanks everyone for watching. Have a great day.